Welcome to today's problem solving class. What we have to do, we have to find the area of red shaded zone. So this is the red shaded zone, and there are actually two right angle triangle. First one is A, C, and B, and B is the right angle triangle, and obviously this is 90-degree, as well as E, C, and D. This is also a right angle triangle because D is the right angle. And here E and C, both this angle is 45 degrees. So this one and this one is equal. It is actually a isosceles triangle. Let's move to solve this problem step by step. First of all, we choose the very first diagram from ABC. So this is actually ABC, and here 90-degree, 60-degree, and 30-degree triangle. Indeed, AB is given 1 unit long. Indeed, the longest length is AC, which will be the double of this AB. Indeed, this will be 2 unit, and as this is right angle triangle, indeed BC will be square root of, because 2 is the hypotenuse of this triangle. By using Pythagoras theorem, this hypotenuse square is equals to 1 square plus the BC length. So BC length is equals to square root of 2 square minus 1 square. Indeed, this will be square root of 3. So up to this length, from B to C, this is actually square root of 3. Now it's time to take DEC triangle. So this one is a isosceles triangle. Let's say this is A and this is A as well, because this two length is isosceles, and the hypotenuse is given square root of 3. Indeed, we could write down by the Pythagoras theorem, hypotenuse square is equals to A square plus A square, or we could write down 2A square is equals to 3. So A equals to 3 by 2, or we could write down root 6 over 2. So we have got the value of A. So here, so DE length will be root 6 by 2, as well as the length from D to C up to this much is also root 6 by 2, because this is a isosceles triangle. Now it's time to take apart from the whole figure to this red shaded area, and at this point, let's say this is a point called P. So what we have to do, we have to determine the area of this PDC triangle, and obviously this is a right angle triangle as well, and D is the right angle, which is a 90-degree, and C is 30-degree. We haven't we haven't uh, the area of this triangle. Obviously, this is our main goal, to determine the area of this triangle. And we have the side length, which is DC, which is root 6 by 2, but we haven't got the value of PD. So this is the height of this triangle. Indeed, what we have to do, we could write down tan 30 degree is equals to the perpendicular of this triangle, that is PD. Let's say PD is H, which is the height of this triangle, and the base is DC, which is the value of root 6 by 2. So what we have to do, we have to calculate the height of the triangle. So H is equals to DC is root 6 by 2, and tan 30 is nothing but 1 by root 3. So we could write down root 2 by 2. So we have got the value of the height, right? So we have got the value of H, which is actually root 2 by 2. Now the area of the triangle PDC is equals to half times the base, which is DC, and the height is PD or H. Now plug in this value, half. DC is root 6 by 2, and PD is root 2 by 2, actually, beg your pardon. So this will be square root of 12 divided by 8. So solving this term, we could write down square root of 3 over 4 unit. This is actually square unit. So the area of this red shaded zone is root 3 by 4 square unit.